We're starting Unit 2 today. This is our first set of notes for Unit 2, naming angles notes. So make sure you have your notes out so you can follow along with me. And let's go ahead and get started. Alright, so we're naming angles. First part of our note says angles. An angle can be formed by two rays with a common endpoint. The common endpoint is called the vertex. The rays are called the sides. So we can consider the two rays that make up the angle the sides of the angle. We name an angle using three letters. This next sentence is probably the most important part. Thing that messes my kids up every year. The middle letter must always represent the vertex. So it's saying when you name an angle, you have to name it with three letters, but the letter that's in the middle must always be the vertex. So you can't just name it with the combination of letters any three ways you want. It's specific now. Use a single letter. Use a single letter if there is only one angle located at the vertex. So there's certain times where you can name an angle with a single letter, but you can't do it all the time. And I'm going to show you situations where you can't use a single letter when we get to the back. When referring to the measure of an angle, use a lowercase m. Yeah. And so an example here, them showing you how they'll call out an angle in like abbreviated form. It's like M, and then it's the angle sign ABC equals 60. So what that's saying there, how that reads is the measure of angle ABC equals 60 degrees. So if you see that written on paper, you shouldn't just say M angle 60, M angle ABC. That's not how you read it. When you see this on paper, these are all symbols. You'll say the measure of angle ABC equals 60 degrees. That's how it's supposed to be read. Alright. Sliding on to the next part. Types of angles. We already know this, so I'm going to blast through. Our first type, and you should all know, an acute. And you should know that an acute angle is less than 90 degrees. Our next one, obtuse. And you should know that an obtuse angle is greater than 90 and less than 180. So it's that in between. The next one, a right angle. You know this equals 90 degrees. Last one, a straight. Equals 180 degrees. Alright. So that's how we classify our angles as either acute, obtuse, right, or straight. Then after that, we're going to just get into some examples. Now this first one I'm going to lead you through a little bit. And then the second one, I'm going to give y'all more leeway. So example 1 down here, this is helping us figure out how to name an angle. I'm teaching you here. Alright. So example 1 says, name the vertex of the angle. The vertex. And if you look at back at the top, it says the vertex is the common endpoint. So what common endpoint do you see on this angle? And if so, that's the vertex. Anybody? Correct. The vertex will be at angle K. I mean, not angle K, I'm sorry, at K. K is your vertex. Alright. Next thing it asks, name the sides of the angle. Now if you look back up at your definition, the rays are called the sides. So you want to name the two rays that make up the sides of the angle. Alright, anybody for this one? Okay, so we came up with ray KJ and ray KL. Then after that, give 3 ways to name the angle. 3 ways to name the angle. So at the top, it says you can name an angle using 3 letters. And importantly, highlighted, it says the middle letter must be always represented by the vertex. And then it says you can use a single letter if there's an angle located at the only one angle located at the vertex. So they're giving you 3 ways. You just gotta think about how to do it. Before I give them to you, let me see if anybody can figure out the 3 ways we can name this angle. Alright, so the 3 ways you can name the angle. Angle JKL. So I named it with these 3 points, but I made sure my vertex angle letter was in the middle. JKL. And then I'm going to name it, coming the other way, LKJ, keeping the vertex in the middle. And then since this angle is by itself, it's a single angle, I can just name it with the vertex itself. I can call it angle K. You can't do this all the time, but in a situation where angle is just by itself, you can. You'll see on the back when we have multiple angles together and stuff, you're not going to be able to use just a single letter like this. Next one is classifying the angle. So this should be easy for y'all. Somebody classify the angle. We just name the angle types up top. Somebody classify using the angle types. Alright, so we call this obtuse. And then next one, example 2. And I expect y'all to be a little bit faster on this one. Example 2, name the vertex of the angle. You get somebody? Vertex is at S. Name the sides of the angle. You need somebody for that? The sides are at SR, ray SR, and ray ST. Next one, give 3 ways to name the angle. Anybody for that? Alright. I call it angle RST, angle TSR, or I can call it angle S. I'm going to add something in just because I think it'll help us for future reference too. So when they got angles like this, sometimes they'll put, instead of a letter at the vertex, inside, or sometimes on the, I don't usually be on the inside like this, they'll put a number. if they got more than one angle connected to each other. And you'll see it on the back too. They'll have the angles numbered in the area where they're formed. If they have a number there for your angle, it's going to be rare that they do, but sometimes they do. You can name that angle using numbers. So if they have a number there and don't have letters or nothing like that, and then you see it, the number where the angle is formed at, you could call this angle 2. That's just an additional piece of information for you to have. You'll see it from time to time. Alright, next thing, classify the angle. This should be easy. I'm not even going to ask for that one. Everybody should know what kind of angle this is. It's alright. Moving to the back. Alright. On the back, we're going to handle some more definitions first. On the back, first thing we're going to talk about is congruent angles. So for the congruent angles, we're going to look at this diagram out here to the right. It's showing you two angles, angle A and angle B here, and they say they both are 75 degrees. So that means these two angles must be congruent. Over here, we're going to write a statement out talking about that. So we're going to say if the measure of angle A, this is my abbreviation, equals the measure of angle B. Bad, my phone is picking up me talking. Alright. My bad, y'all. Then the angles are congruent. This is written as angle A is congruent to angle B. What I'm saying is they're congruent. So that's congruent angles. The next one, angle bisector. We went over the word bisector before. You should know that it splits things in half. That's what a bisector does. Alright, so in this case, for an angle, and we're looking at this situation over here, if you have a bisector and an angle, it's going to be a ray that divides an angle into two congruent angles. Okay. So in the diagram to the right, this one we're looking at over here, you see the situation. You have a big angle ABC being cut by the bisector BD, and then it's splitting this angle, big angle, into two congruent smaller angles. And so that's what we're going to write about over here. So it says in the diagram to the right, ray BD is an angle bisector. Therefore, the two smaller angles, which will be angle ABD, is congruent to angle CBD. So let me show you that over here. So we said we got the ray BD coming in and bisecting this big angle, and then splitting it into two smaller angles here and here. They even indicated to you that's what these markings are for, showing you that these angles are congruent in here. So you got the angle ABD, which is congruent to the angle CBD. Now knowing that, the significance of knowing that is knowing that, okay, if they give me one of these angles, say either the big one, the whole thing, ABC, or one of the two smaller ones, ABD or CBD, I can find any of the other angles just by knowing one of them. For example, let me get y'all to thinking real quick. Out to the side here, say if I give you this piece of information, say if I tell you angle ABD equals 35 degrees. Say I tell you that angle ABD equals 35 degrees. I tell you that, and then I ask you this: I ain't gonna write a whole sentence out because I don't have room. Basically, I'm gonna ask you, what is ABC? So, ABC equals what now? If ABD, that angle equals 35, what does angle ABC equal? Let's see somebody give me that answer. Give us an explanation too. Alright, so after we talked about, yeah, like I said, 70 degrees. Reason being, ABD is this angle right here. And if this is a bisector, that means this angle, one is half of the big angle, and it's also, half of this other. I mean, this other angle and it are congruent. So, like in here, I could write 35 degrees and then 35 degrees on these two angles because I know they're both 35. And then the whole thing would have to be 70 if you add them correctly. Alright. Next thing, perpendicular lines. Keep my paper straight. So for perpendicular lines, two lines that intersect, y'all should know that already, at a right angle. So when they intersect, they create a right angle. That's how you know they're perpendicular and not just regular lines that are intersecting. The symbol for perpendicular, you've already seen this, but I'm going to draw it again for you. And it's the upside down T look like, but that's the symbol for perpendicular. In the diagram over here to the right, they're showing you two lines intersecting, and then they create a right angle right here. This is how you know they're perpendicular. So in the diagram to the right, I see L, which is a line, is perpendicular to M. That's what they're showing me. And the other thing you need to know about this too, perpendicular, they're only ever going to put one box right here showing you that it's right angles created. But you need to understand, if you only got two lines intersecting and they're perpendicular, you're going to have all right angles, not just that one. This is a right angle, this is a right angle, and this is. They're not just going to draw all these boxes for you though, because I mean, it don't make sense to. Once you know you got a right angle right now, there you should know all those angles are right angles. You should know all the angles are 90 degrees. 90 here, 90 here, 90 here, and 90 here. You should know that just by looking at them. Alright. Next thing, perpendicular bisector. Perpendicular bisector is a line, a segment, or a ray. Perpendicular. If you don't know how to spell the word, it's out there to the left. To a segment at its midpoint. In the diagram to the right, they're showing you a couple things. They're showing you that this line LM is cutting through this segment right here. Okay. Now let me talk to you about the difference between perpendicular lines, perpendicular bisector. Up here you have perpendicular lines. This isn't considered a perpendicular bisector because it's two lines intersecting. Lines go on infinitely. You can't measure a line. For a perpendicular bisector, you have to have a line, a segment, or a ray cutting through a segment. That's what makes it a bisector. Since I can measure a segment, if I have something cutting through it at its midpoint, then I know it cuts it in half. Up here, I don't know if this line is getting cut in half because this line goes on infinitely in each direction. I don't know the measure of the line, so I can't say that that's a perpendicular bisector. I can only say that this up here is perpendicular lines. But down here, since this is a segment being cut, and if it's cut in half, then I could call this, whatever cuts it, a perpendicular bisector. That's the difference between these two. It's now it's a segment being cut, and then they even show you on the segment where you got congruent here and congruent here. So from the midpoint to P and from the midpoint to Q, those lengths are congruent, equidistant. There go that word again that we learned before. So from the midpoint to P, from the midpoint to Q, that's equidistant. Alright. So in this case, this is a perpendicular bisector. Everything shows me that. So in the diagram to the right, in this case, it's a line coming through. Line LM is the perpendicular bisector to segment PQ. Notice the difference in my symbols. I did a line symbol, then I did a segment symbol. Alright. That being said, let's come down here and answer some more questions. Do some examples. This is example number 3. My little 3 got cut off, but you get it. I head to the left. First one, let me zoom in a little bit since we got space. Alright. Now I can see. First one, write another name for angle CBF. Another name for angle CBF, part A. Anybody? Another name for angle CBF. Yeah, I would just take it the other way. Angle FBC. Now, it's important that you understand. This is where you can't do the one letter. I know some of y'all probably saying, well, I could call it angle B. If you're going to call it angle B, how do I know which angle you're talking about? Because B is the vertex for all of these angles. If you say angle B, I don't know which angle you're talking about. You could be talking, you say angle B, you could be talking about angle ABE. You could be talking about angle ABD. You could be talking about angle DBF. Or the one we just did, FBC. Or you could be talking about CBE. I don't know what angle you're talking about. This is when you can't name an angle with a single letter. That's why most of the time I just name all my angles with 3 letters. Because you have to be specific. Alright? And the vertex always has to be in the middle, once again. When I say FBC though, you should know exactly what I'm talking about. When I say FBC and you follow your pen around, you're like, oh, okay, he's talking about this little angle right here. It should be easy that way. Don't make it harder for yourself than it has to be. And this is one of those main things, reading angles like this, especially when there's multiple on a diagram. If some kids if you don't pick this up now, you will struggle with it the whole year. And it's an easy thing to do. But it's easy not to pay attention today too. And we talked about this before. And this is what happened with some of y'all on the last test. Y'all zoned out in notes and stuff, didn't finish notes. And then you wonder why you don't know certain things. This is important. Learning how to name angles. You're going to be dealing with angles for the rest of the year. If you don't learn how to do them now, you won't know how to do them. So if you ain't been on point so far in these notes, go ahead and switch your attitude and get on point. Learn how to name angles today. The next thing, naming the sides of angle EBD. So we just want to name the sides of angle EBD. Anybody, you should know what the sides of an angle are. We did it on the front. Alright, for EBD, the 2 sides would be ray BE and ray BD. The next one says classify angle ABC. Classify angle ABC. Anybody? Good. You should have seen it as a straight angle. D. Give an example of an obtuse angle. Look on this figure and name an obtuse angle for me. There's multiple options here, and there's no right one or wrong one. Just give me a name of an obtuse angle. Alright. So the 2, I'm going to write 2 for you. The 2 I chose, and these is Probably not the only ones. I have to, yeah, no, they're not going to be the only ones. These are just the two I chose. Angle E, B, C, and angle, I'm going to go with the other one that's congruent to it, angle F, B, A. Those will be examples of obtuse angles on this diagram. And then name two congruent angles. So we're naming two congruent angles, two angles that have the same measure. The easiest ones on here, you should be able to see it, but there's more than one set of congruent angles on here too. Anybody? So the ones I would have named, angle A, B, E, and angle CBF. Those are two I would have called congruent. One, because they mark both of them congruent, so I can easily see that. There's this congruent markings for an angle right here. Arc markings here and here. But those aren't the only pair. Like I said, we'll talk about some other ones. Alright, next thing, F, name a perpendicular bisector. So you're naming a perpendicular bisector. You have to be specific about this. You got to name something that's bisecting a segment on here. And they're kind of showing it to you. You just got to name it correctly and tell what it is. You got to name it. It's either at the top, like I said, a perpendicular bisector could be a line, a segment, or a ray. Name it correctly. Anybody? Alright, so yeah, so based on our markings that we saw on here, segment going to a segment here, AC, and you had AB congruent to BC. I see my bisector being ray BD. This ray right here is bisecting these two. Let's move on to our last section. So I got example 4 here. And so the 4 got wiped off. It's all good though, we can see what we can see. Name the vertex of angle 1. Name the vertex of angle 1. This is for anybody. Alright, yeah. And so you should have noticed too where they got the numbers going in this one. And they're naming the angles with the numbers. So the vertex of angle 1 would be T. Honestly, it's the vertex for all the angles, if y'all notice. Name the sides of angle 4. So you got angle 4 there, locate where angle 4 is. They want you to name the sides that create angle 4. Once again, remember what sides are created by on angles. I mean, what creates, or, you know, what do we name the sides? Alright. So my two sides and everybody's two sides on this one should be TW, ray TW, and ray TZ. Those make up angle 4 for me. Write another name for angle 3. So you're going to have options on this. For angle 3, write another name. And whoever answers it, I want you to name the 2 ways. There's only 2 other names you can make this angle. Name both of them. Alright, so we should came up with angle ZTU and angle UTZ. You can't use a single letter once again because T goes for every angle in here. so you can't use the single letter on this. Classify angle YTW. Classify angle YTW. Anybody? Yeah, once you locate that angle, this should have been easy. So, right. There you go. Part E, name two perpendicular lines. So name two perpendicular lines. Alright. On this one, and it depends on how you named your lines, but I took the route of going for the furthest points, just so it could be obvious. So I named the two perpendicular lines as line YZ, and then line WX. But you could have said line YT and then line WT and not have been wrong. You could have said line ZT and line XT and not have been wrong. Remember, any 2 points on the line you can name a line with. But to keep it clean and not to use the same letters over and over, I just went with my furthest points. But once again, as long as you're naming points on that line, you're not wrong. Last thing, name an angle bisector. Name an angle bisector. Somebody finish this off strong. Alright, good. Angle bisector for this one is going to be ray TU. Ray TU. The indicator right here by showing these two angles, 2 and 3, are congruent to each other. And then you got this ray split, so this ray has to split them. Right here. It's splitting this angle. I'm trying to, yeah, let's do this. It's fun. Let's do it again. So on this one, just giving you an extra piece of information before we dip. This one, you got a right angle right here. So you know these two lines are perpendicular. We even said it above. So if that's the case, that means, like we told you before, right angles all the way around here. Here, here, and here. Teacher moment. If you got a right angle here, right angles all the way around, so you know, like we said, 90, 90, 90. I'm not going to write my 90 in here. But if it's a right angle here, and we call TU an angle bisector in the middle of this angle, what is angle 2 and angle 3? What's the value of angle 2 and angle 3? Somebody impress me before we go. Exactly. If that's the case, you're going to have 45 degrees here. You're going to have 45 degrees here. Alright, so that's the end of our notes. Like I said, watch the video as many times as you need. If you didn't finish filling out your notes for some reason, something happened, finish your notes. There's no reason to sit there and go into a practice or anything like that if you got incomplete notes. Finish your notes. Alright, thank you.